Hello and welcome to the fourth section of this video course. This section is related to hyperparameter optimization on SageMaker. In this video, I'm going to summarize all the available hyperparameter optimization methods that you can find out there, but I'm not going to dive into the theoretical details of them. Here I'll list 5 different approaches of performing hyperparameter optimization or tuning. The first one is grid search, then random search, evolutionary optimization, gradient-based optimization, and Bayesian optimization. Let's start with grid search. It's a traditional and naive approach. It's simply exhaustive searching through a manually specified subset of the hyperparameter space of a learning algorithm. I show you here a Python snippet where we specify some parameters for an SVM. This will result into 8 different combinations, and grid search is going to evaluate all of them exhaustively. Here I enlist some libraries that offer grid search functionality: scikit-learn, Talos for Keras, and Optunity. I've used Optunity in the past, offers different and more sophisticated ways to perform search over the hyperparameter space. Random search is another traditional approach, not sophisticated, but more efficient. It replaces the exhaustive enumeration of all combinations by selecting them randomly. So, as before, all the exhaustive combinations are going to be 8, but I specify n iter search to be 4. So, random search is going to take randomly 4 combinations and evaluate them. So it's going to be faster, as we don't have to go through the entire hyperparameter space. Scikit-learn offers random search, Optunity as well, Talos for Keras, H2O AutoML, and Hyperopt. Evolutionary optimization. It's a very classic approach for the global optimization of noisy black box functions. If you ever done an operations research or computer science degree, you have probably get taught about these algorithms, such as genetic algorithms, particle swarm optimization, and ant colony optimization. Teapot is a very popular library that uses genetic algorithms in order to traverse through the hyperparameter space in a very smart way. I've used it. It's very efficient and easy to use. Optunity uses swarm intelligence to perform the same task. Gradient-based optimization. This is a more analytical approach to perform hyperparameter tuning, where you can compute the gradient with respect to hyperparameters using gradient descent. It has been applied to neural networks, SVM, and logistic regression. It's not a very popular method as the rest of the others. Hypergrad is a Python library that offers gradient-based optimization, hyperparameter tuning. Bayesian optimization. It's a very popular approach nowadays, and this is the approach that SageMaker offers. As in evolutionary optimization, it is a global optimization method for noisy black box functions. But instead of getting inspired by nature, as ant colony optimization or genetic algorithms, it builds a probabilistic model of the function, mapping from hyperparameter values to the objective function, evaluated on a validation dataset. It gathers observations to update its beliefs after each iteration, and it tries to balance exploration versus exploitation. To sum up, Bayesian optimization has the ability to reason about the quality of experiments before they are executed, and this is a really powerful trait. Here I list 2 Python libraries that perform Bayesian optimization. I've used AutoScaleLearn in the past. Another library is Hyperopt.